Good morning, everybody. I hope everyone's having a better time adjusting, and I hope everyone's doing well and safe and healthy. I hope all your families are well and safe and healthy. Miss you guys a lot. This is starting to wear thin on all of us, I feel like. So hopefully everyone's doing well, and hopefully I see you guys come September time when school starts back. But for now, we have to do some math lessons. So what we have in front of us is a new lesson for a new unit. Now we're done with the number systems, we're done with all that stuff. We're doing something completely new and something very easy called arithmetic sequence. Okay? Arithmetic sequence is pretty much finding patterns and find the next number in the patterns. That's really it. Okay? So your nuke agenda says Haley thinks that the product of 3/7 and radical 8 is an irrational number. Is Haley correct? Explain your reasoning. So why don't you guys take a little pause right now and try to solve that, and then we'll come back to it, and I will show you guys exactly how to do it. Okay, so what we're going to do here is pretty simple. We're going to look at what the word product means. I hope everyone remembers that the word product means multiplication. Okay. And then we're going to multiply 3/7 and radical 8. That's all we're doing. And we're looking to see um, what the end result is. Remember our rules for rational and irrational numbers. If it's a decimal that stops or a decimal that repeats, it's a rational number. If it's an ongoing decimal, it's an irrational number. So we have 3/7 multiplied by radical 8. Enter. As you can see, this is a radical. Now, it's kind of confused right now because the first four terms seem like they are repeating, but the last ones don't seem like they're repeating. So in order to really make sure, if you're ever not sure, you need to double check. You're going to press math, frac. If it turns into a decimal, it is a rational number. But as you can see here, it did not turn into a decimal. It stayed I'm sorry, it did not turn into a fraction. I apologize. Let me repeat that. Let me fix that. It's also early in the morning for me. After you multiply, you get your decimal. After you press math, frac, you should be getting a fraction. If you do not get a fraction, that means it's an irrational number. If you did get a fraction, then it works. But if it did not get a fraction, then it's an irrational number. So once again, looking back at our question, is Haley correct? Haley said that the product is an irrational number. Yes, because the decimal is ongoing. Oh man, my writing today is gonna be a problem. Hopefully that gets fixed soon. All right, so now let's look into today's lesson. Again, today's lesson is called an arithmetic sequence. So the first thing you need to know is, what is a sequence? Well, a sequence is just a list of numbers. Any list of numbers you can think of as a sequence. An arithmetic sequence, though, is when you can specifically add or subtract a number. Okay, so arithmetic sequence is a sequence in which you add a specific number to get the next term. The other vocabulary word that we're going to be using a lot today is called common difference. All right, the common difference is the number you add in an arithmetic sequence. Another word I want you guys to think of for common difference is your pattern. All right, you're just looking for your pattern. You're just trying to figure out, all right, what number can I keep adding? Sorry about that. You're trying to figure out what number can I keep adding to everything to get the next number to fit the pattern, right? So let's take our example. We have 2, 5, 8, 11, 14. So is this an arithmetic sequence? The first thing you got to ask yourself is, are you consistently adding the same number to each one of these to get the next number in the sequence? So yes, you are. I hope you guys notice that that's my fault. Hold on, let me fix that. Give me 1 second. There we go. All right, so I hope you guys notice that yes. Come on. Why is this acting like this today? There we go. Yes. I hope you guys notice this common difference because the common difference is going to be 3. All right. Your common difference is 3 here. That means you're adding 3. Sorry, guys. My iPad's acting a little funny right now. I don't know why. That means you're adding 3 to each number in the pattern to get the next number. Okay? So, we give every term a specific name. So, our examples here, A is going to be what represents the term in the sequence. So, for example, our first term is A1. A1 is 5 because that's our first term in the sequence, right? So, A1 is 5. A2 is our second term in the sequence. So, A2 is 9. A3, which is our third term in the sequence, A3 is going to be 13. All right. And then our fourth term in the sequence, A4, is going to be 17. All right. So that's just so you guys see, whenever you see A1, A2, A3, A4, that represents the number in the sequence. Excuse me 1 second. Gross. Excuse me. So whenever you see A1, A2, that's the number in the sequence. If you ever see AN, so like that, AN is going to be what we're looking for. That's the term we're looking for. All right. So we can write that down now just in case you guys want it. Term we're looking for. All right, so that's what AN represents. AN is the term that we're looking for. Okay. All right, so let's look at some examples now. Oh, before we do that, I'm sorry. We actually have a formula here to copy down. Please copy this down now. All right. Very important that you have the arithmetic sequence AN. The common difference is going to be represented by D. That's our pattern. All right. And N is going to be the term we're looking for. These two things are going to be connected. All right. Oops, sorry, not those two things. These two things, AN and N, those are going to be connected because in order to know what term we're looking for, that's going to be our nth term, right? So if we're looking for 15, that's going to be our 15th term. 15 is going to be where N is. All right, and I'll show you a good example of that in a second. So make sure you take a second right now and you copy this stuff down. All right, please. Okay, I think by now you guys probably have copied it down. Just give you guys another second because I know, kids like Michael McGlone and Camille and all you scrubs, you don't really copy down this work quickly. George is probably there drawing a picture. Chris F is probably cackling. Coonjang is probably tell Chris F to shut up. So since you're all distracted, I'm giving you some time to finish copying. Okay, so let's look at an example now. So we just want to find the common difference, just trying to find the pattern of each one. All right, that's all we need to do, and then we find the next two terms. So for number 1, we have 5 going to 12, 12 going to 19, 19 going to 26. The easiest way, if you can't tell just by looking at it, I added this number to 5 to get 12. I added this number to 12 to get 19. If you can't tell that, that's okay. What you should do then is just subtract. All right, subtract the second number from the first number, or pretty much just subtract the next number in the sequence from the previous number, right? So it doesn't really matter which way you go. If you want to do 12 minus 5, like this, or if you want to do 19 minus 12, or if you want to do 26 minus 19, it doesn't really matter because they all give you the same answer, which is a positive 7. All right, so your common difference here, all right, or as they say, CD, is going to equal positive 7. Let me rewrite that positive 7 for you. That kind of looks Kind of trash. Kind of trash. Just like Kevin Hortz's haircut probably right now. All right, so we're going to add... I miss you guys so much. I just can't stop making fun of you. We're going to add plus 7. All right? Now, the next step is to find the next two terms. So we just add 7 to the next two terms. 26 plus 7, I hope you guys see, is 33. And then 33 plus 7, I hope you see, is 40. Okay? So those are your next two terms. So that's all you're doing. You're subtracting the previous term from the, you're subtracting one term from the previous term and finding your common difference and then adding it to each. The only reason I'm not saying is subtract the bigger number from the smaller number is because sometimes our common difference will be a negative number. And if that's the case, then we can't subtract the biggest number from the smallest because then we'll get a positive answer probably. All right? So we always have to subtract just in whatever order they give us. All right, so let's look at the next one. We have a negative 7x minus 4x, all right? Minus x and 2x. So we're trying to figure out what the next pattern is, what the next number is. So our common difference here, once again, just do what I just told you to do. Take negative 4x and subtract negative 7x. I hope you guys remember a double negative gives you a positive, and negative 4x plus 7x is 3x. All right. And again, if you add 3x, negative 4x plus 3x is negative 1x. Negative 1x plus 3x is positive 2x. All right. And then if we continue that, 2x plus 3x is going to give us 5x. And 5x plus 3x is going to give us 8x. All right. So those are our next two terms in that one. And number three is a little difficult, but pretty much the same concept. Just remember, like terms with like terms. All right, I'm going to erase this whole side over here. So this way I could just use this space, all right? Just erase all that. There we go. Oh, and actually for number 2, we forgot to write the common difference. Plus 3x. And guys, always include your sign when you're doing the common difference, just because it's going to help you remember it. So as you're doing problems, you just have it to the side there. It helps you remember. Cool. All right, next one. We're going to do 4a plus 4 minus 2a plus 1. All right, so remember to always distribute that negative, so it's a negative 2a, and now that's going to become a negative 1. So 4 minus 1 is 3. 4a minus 2a is 2a. So our common difference we're saying for this one move all that out of the way. So we're saying the common difference for this one is 2a plus 3. And that makes sense. 4a plus 2a is 6a. 4 plus 3 is 7, right here. 6a plus 2a is 8a. 7 plus 3 is 10. So that makes sense. So what are the next two terms now? So the next term is going to be 8a plus 2a, which is 10a. Oh, sorry about that. Let's erase that. Fix that. My apologies. Try that again. So 10a. And 10 plus 3 is 13. Then after that, we're going to have 10a plus 2a, which is 12a, and 13 plus 3, which is 16. All right. So that's just how you find the common difference. Just really wanted to make sure you understood that and went over it. Okay. So once again, subtract the second term from the first term, or the third term from the second term. Whatever term you pick, just subtract it from the previous one. All right. And that's what helps you find your common difference. All right. So let's use this in a problem now. So in the sequence, the first term, so now we're going to start labeling stuff, all right? So remember, our first term is A1. So our first term is 4. The common difference is positive 3. Find the fifth term of the sequence. So Real easy. For this one, we don't do any formulas. It's only the fifth term. It's a small number. So we'll just write it. So our first term is 4. 4. I'm going to use a different color here. Give me 1 second. All right. So then we have 4 plus 3. And we have 4 plus 3. That's going to give us 7. 7 plus 3 is 10. 10 plus 3 is 13. How many terms is that so far? 4 terms. We need one more because we're looking for the fifth term. All right, don't forget that. We're looking for the fifth term. Oh, well, that's not where I want that. Let's fix that. Nope, that's not where I want that either. Hold on. There we go. We're looking for the fifth term. All right. So one more then by my calculation. 13 plus 3 is 16. So A5, which remember is the fifth term, is equal to 16. All right. So that's just an easy way to do it. Adding 3 every single time to each pattern. And when there's small numbers like this, when they're asking for a small pattern, you guys can do that. And that'll be fine and it won't take up too much time. All right. So that's fine. When we get to the bigger numbers, we're looking for larger numbers in the pattern. That's when we will use the formula, which we'll look at again. Don't worry about it. It's a pretty easy formula for you guys to follow, all right? All right, this one wants you to write an equation to represent the nth term of the sequence. So first thing we got to remember is our formula, all right? So let's go back there really quick just to make sure you guys have it, because I know some of you guys don't. So our formula, an equals a1 plus parentheses n minus 1 times d. All right, so that's what we're going to be writing here. an equals a1 plus n minus 1 times d. And if you guys look at it, should be the same thing we have here, same thing here. All right. So they want us to write an equation to solve this. So look at what we have in the equation, and look at our formula and see what we need to plug in. Right now, we have to plug in a1, which is our first term. We cannot plug in n because we don't know what term we're looking for. Remember, we're just writing an equation. We're not looking for a specific term. So right now, n stays n because of right here. All right, n stays n. Why is this so off today? I'm sorry, guys. There we go. N stays n. But we need a1 and we need d. All right, those are our two variables that we're looking for. So a1 and d. Remember, d is our common difference. That's our pattern. All right. So a1, that's our first term in the sequence. Our first term in the sequence should be 33. All right. That's pretty simple. That's the first term I see. Our pattern. Remember, our pattern, we're subtracting numbers. So in this case, we're doing 25. I'm going to put it next to it here. 25 minus 33. Remember, it's not the bigger number that goes first. It's the second term and the first term. All right, so the second term always goes before the first term. All right, so 25 minus 33, I hope you guys know, is a negative 8. So our pattern is a negative 8, okay? Not a positive, a negative, because we're going down. And that makes sense. You can't add to get from 33 to 25. You have to subtract. You have to subtract to get from 25 to 17. So that makes sense. That's not a big deal. All right. So now that we have our pattern, now that we have our first term, let's just write our formula. All right. I'm going to put the formula right next to the 33. Just put an arrow there. So our formula is going to be an equals 33 because that's our first term plus we don't have n, so we leave n alone, n minus 1, times d. And d is negative 8. That's our pattern, all right? So this is our formula that they're asking for. That's what they want. All right, pretty straight up, nice and simple. Okay? All right. Now they want us to find the 15th term, and now that's a lot. Again, if you want to, you can definitely just add to, till you find the 15th number, but that's going to take some time. You might miscount, you might add incorrectly. There's just a lot of variables that you don't want to take the chance of. So instead of adding, let's use the formula, all right? Now that we're kind of familiar with it a little bit, let's get really familiar with it. So let's rewrite it first, like we always do. So an equals a1 plus n minus 1 times d. All right, so now that we have everything we're looking for, now let's plug in everything here, all right? So we're plugging in an, we're plugging in a1, we're plugging in n, and we're plugging in d, all right? So an is the only one that we can't plug in because that's what we're looking for. That's our answer, okay? So we're not going to be plugging in an. A1, that's our first term. Our first term is 5. N is the term we're looking for. All right, so go back to the question. They're asking for the 15th term of the sequence. So N is actually going to be 15. And that kind of can come back up here. Even though we don't know what AN is yet, we're going to rewrite AN as A15. All right, it's not going to be AN, it's going to be A15. Okay, and then for our common difference for our pattern, we got to figure out what number is being added to each. So subtract the second term from the first term. 13 minus 5, which gives you a positive 8. All right, so positive 8. So now we're just going to plug all this into our formula. All right, so let's go over here. I'm going to write the formula in blue just because blue is a cool color to me. So we're looking for the 15th term. So A15 equals A1, which we know is 5, plus parentheses N, which is 15, minus 1, and then we're going to multiply it by 8, because 8 is our common difference. So, as long as I write this correctly, I'm just going to plug this into the calculator. All right, so let's move the calculator over a little bit. Let's clear that out of the way. So we have 5 plus 15 minus 1 times 8. And like we always tell you guys, just write exactly like you have it in the calculator. As long as you do that, it will always be right. So our answer in this case is going to be 117. 117. So we're going back here. A to the 15th equals 117. Bam. Nice and easy. It's just identifying. The hardest thing you have to do is find the common difference. That's it. The hardest thing you have to do is down here, which is finding this. That's the most math you have to do. Everything else you just plug in and you solve. So this is a nice, easy lesson for you guys, all right? All right. Few more questions until I give you guys your group work. All right, so let's go to the next question. So this question is a little complicated, not too much. We do have to use something from our past in order to help us out here. So it says an arithmetic sequence has a first term of 10 and a sixth term of 40. So it's not giving you all the terms, it's giving you very specific terms. All right, so if we write out the sequence, pretty much what it's saying is here's 10. 1, 2, 3, 4, 5, and then here is 40. And you don't know the numbers in between. And they want to know what the 20th term of this sequence is. Okay, so let's start out like we just did the last one. So we know AN is going to be A20, which is what we don't know, which is what we're solving for. Okay, we know A1 is equal to 10. We know N is equal to 20, because that's the term we're looking for. And we're looking for D, which is our common difference. Now, normally, you would subtract, the second term from the first or the third term from the second. But in this case, we only have the first and the sixth term, okay? So what you have to use here, and I don't want to hear any groans, because I can hear them through the computer. What you have to use here is the slope formula, okay? So I know that's a little annoying, but it is what it is. No big deal. But we do have to use the slope formula. So here we go. Remember, slope formula is, I'm going to go down a little bit. Remember, slope formula is y2 minus y1 over x2 minus x1. In this case, your y's are the number and your x's are the terms, okay? So 40 minus 10 over 6 minus 1. 40 minus 10 is 30. 6 minus 1 is 5. And 30 divided by 5 is, 6. Okay? So what they're telling us is that the sixth term, is that 6 is our common difference. which makes sense. If you add 6 to 10 5 times, you're going to get 40. All right, I promise you. You can check it right now in your calculator. So our common difference is plus 6. Now let's go back up here now that we got the common difference. All right. You know what? Let's leave it here. I think if you guys want to see the rest of the work, you can go back up and pause. No big deal. Actually, I can make it a little bit smaller if that would be beneficial. There we go. Look how good I am. All right. So once again, we're going to blue because we're going to put in our equation and answer. So we have A20 is equal to 10 plus 20 minus 1 times 6. So remember, 10 is our first term, 20 is the term we're looking for, 6 is our common difference. So 10 plus parentheses, 20, make sure you put those parentheses, 20 minus 1 times 6, which is 124. So they're saying A20 equals 124. Okay. Oh, right. So that's pretty much how hard it's going to get, is when they just give you different terms and not the entire sequence. All right, it's not going to get that much harder than that. Let's see if we have one more question. We have 2 more questions. All right, 2 more questions, and then we will call it a day. So number 8, in an arithmetic sequence, A4 equals 19 and A7 equals 31. Write a formula. Now remember, they're saying formula. They're not saying to solve. They're not looking for a specific term. They're saying write a formula. All right? Write a formula. Okay, so first thing we have to do is figure out, we're not figuring out AN. We're leaving AN as it is. We got to figure out our A1 and we got to figure out our D, because those are the 2 that are going to matter. Okay? All right, now obviously, they didn't even give us the first term here. They gave us the 4th and the 7th, those annoying jerks. All right, so the first thing we gotta do is find the D then, because we can't find A1 because we don't have the first term. So we have to find our common difference, which is our pattern. And just like the last problem, they only gave us specific terms, so we have to use our slope formula again. All right, so y2 minus y1 over x2 minus x1. So in this case, we have 31 minus 19 over 7 minus 4. All right, so that gives us 31 minus 19 is 12. 7 minus 4 is 3. And 12 divided by 3 is 4. So our common difference is plus 4. Now, in this case, we do have to work backward a little bit, because now we gotta get our first term. So we have our 4th term, which is 19. I'm gonna write over here in the formula. We have our first term, which is 19. All right, but we need to find our first term now. So 19 minus 4 is going to give us 15. That's A3. 15 minus 4 is going to give us 11. That's A2. All right, because remember, 19 is A4. And then 11 minus 4 is going to give us 7, and that's our A1. And guys, the reason I have to work backward is because we're not looking for terms ahead of it. We're looking for the first term. So we got to go backward. We got to do the opposite of our pattern. Our pattern is plus 4, and we have to go backward, so then it's minus 4. All right, so our A1 is 7. So our formula is AN equals 7 plus n minus 1 times 4. All right. Hopefully that one wasn't too complicated. I know that was a weird one. I apologize, but hopefully that wasn't too bad. Okay. All right. Last problem of the day, and then you guys can work on your practice problems with no issue. Okay. The 3rd term in a sequence, in an arithmetic sequence, is 10. The 5th term is 26. Write an equation just like the last one. We're writing one more equation. All right. If you want to pause it and try it on your own and see if you get the same answer, do so now. Otherwise, I'm about to start. So, AN, we know we don't have to find. We know we're looking for A1 and we're looking for D. All right. And we know that since we have the third term and the fifth term, we gotta do our slope formula in order to find this. All right, so we're gonna do 26 minus 10 over 5 minus 3. 26 minus 10 is 16. 5 minus 3 is 2. 16 divided by 2 is 8. So our common difference is plus 8. Let me lower that. Sorry about that. All right. So again, we did 26 minus 10 because those are our numbers, and then 5 minus 3 because those are our terms. All right. 16 over 2, which is 8. Okay. Now we got to work backward. So we know that our third term, our A3, we know is 10. So we have to subtract 8 to get A2, which is 2. And then we have to subtract 8 again to get A1, which is 2 minus 8, negative 6. So our first term is actually negative 6, okay? All right, now we can just write our formula. I'm going to use the space right above actually, no, I'm going to put it over here. I lied. I like to lie sometimes. AN equals negative 6 plus n minus 1 times 8. All right. All right, guys. So that's pretty much all it is. Look back on the slides if you have any questions, if you're not sure about anything. Otherwise, this will be it. When I go to the next page, please give me 1 second because I need to make sure it all fits in the screen, and then you can pause it and see if and do your work. There should be about 7 questions. All right, let me just give you 1 second. All right, so those are your questions for today. The first 3 are pretty easy. You just find a pattern, so no big deal there. A lot of these questions are pretty simple, so I'm pretty sure you guys are gonna get it pretty quickly. All right. As always, I will be on office hours later today to help out with anything you need. Just even show up to say hi. I miss you guys. I haven't talked to some of you guys in a very long time. I hope everyone's doing well. I consistently see Allison and James and Elizabeth, but not really anyone else too much. So I'd like to see some of you other guys as much as possible. All right. All right. Have a great day, guys. Stay safe. Stay healthy. I'll see you guys soon. Peace out.